Buenos días a todos. Les pedimos perdón por la pequeña demora en empezar esta charla. Tuvimos algunos problemas técnicos, pero ya estamos listos. Mi nombre es María José Izaza, soy la directora sectorial de Acoplásticos y hoy les voy a acompañar como host de esta charla, que será en inglés para que todos sepan, y es BYK Plastic Additive Solutions for Packaging por AZELIS y BYK. Para contarles un poquito, AZELIS es una empresa líder en la distribución de productos químicos y especialidades alimentarias con presencia global en más de 60 países. Ofrece soluciones innovadoras y sostenibles para la industria como la farmacéutica, cuidado personal, alimentación y química industrial, apoyada por una red de más de 70 laboratorios de aplicación. En Colombia, AZELIS ha fortalecido su posición, consolidándose como un aliado clave en la cadena de suministro local. BYK también es un proveedor líder mundial en especialidades químicas. Y antes de pasar la palabra a nuestro speaker Hans, les cuento para que lo tengan en el radar, este es un evento pago, el contenido presentado por los expositores en las diferentes sesiones de la Semana del Plástico no refleja necesariamente la posición, valores ni políticas de Acoplásticos. So, Hans, I think we are ready. Thank you for your time, and the floor is all yours.
Yeah, thanks a lot. Okay, my name is Hans-Jürgen Eichler. I'm based here in Wesel, which is in Germany, quite close to Düsseldorf. And yeah, again, a warm welcome from my side. Today, I want to speak about the additives and solutions for packaging applications and allow me a few words about BYK, who we are and what we are doing. So we are more than 150 years old company, and the name BYK is coming really not as an association. It's a real guy which founded the company. He was called Heinrich Bück, so no translation from anything. So it's really his name. And a few figures which you find on here saying how big our company still is and what we are doing in sales. So I don't want to blame you with all these figures. Interestingly, saying that we are 2,600 people worldwide. We have 1.4 billion euro in sales. We have different laboratories all over the world, different production places all over the world. And so the main groups which we are producing, or additives which we are still producing, are wetting and dispersion, surface additives, rheology, defoamers, wax, adhesions, viscosity reducer, processing additives. But that's not all for plastics. So BYK is quite great also in the paint business. And I will touch that point a little bit later on. But the main focus should be for today, the plastics. Here is a slide showing where we are worldwide, and maybe your major interest might be South America. And for the time being, we have one lab, which is in Brazil, in Sao Paulo. Here we have a cooperation with Colormix, and we use same service laboratories. But it's planned in the near future to do something more in South America, because we see that the market here are very interesting and it looks like nice potential for growing. So coming now to a little bit closer and saying what we are doing in plastics, you see here our opportunities. That's, by the way, our lab where we are in the ground floor. And that's still an old picture from our twin screw extruder. We have burning facilities to check different flame retardants. We have a cast film line. We have injection molding. We have several things to test in our laboratories. And one of the major points which I want to touch is we have 5 thermoplastic brands, let's say it in that word. We have the BYK, which are still solutions to optimize processing and improve the material properties like flame retardants, UV stabilities. And beside that, we have the products called BYK that are classical solutions for wetting and dispersion, for release additives, for rheology and viscosity. And we have our brand, which is called Skona. That's an adhesion promoter, compatibilizer, and coupling agent. We have the Chloesite, which is modified phyllosilicate. So it's sometimes called clay. And that's used in thermoplastics, that's flame retardants, and might also improve physical properties. And beside that, it's also improving the barrier properties. The last brand which we have in our thermoplastic group is Recyclo. That's still speaking for ourselves, I think. It's mainly formulations which increase the quality of recyclates. So today I want to focus on not all the brands, because then it takes hours before I have to stop. And the major point today is SCONA, so compatibilization and coupling agents, the chloicide, the improvement of the barrier, and beside that, the BYK material to optimize the processing and mechanical properties. So starting now with a short introduction, if we speak about packaging, the major drivers which we see in the market are still the source reduction, so means down gauging, lightweighting the packaging, and of course simplification of packaging materials, so color design, might be interesting to have mono materials. And the major, I would say, polymers which we see in the market right now are PET, PE, and polypropylene. And beside that, still the biopolymers are getting more and more of interest. Beside that, there are a few certain materials which seems to be banned, especially if you look for the fluorinated stuffs. Also here in packaging, there are stories for the processing additives. And of course, the recyclability of multi-layer materials. That also the major points which we see in the market for the plastic packaging. Oops, there was one too fast. So if we want to focus now the barrier additives, of course, there are variables affecting the permeability. So there is still the chemical structure of the permeant, which is interesting, the permeant concentration, the temperature, humidity, all that is still given from your application, means your packaged good which you placed in the plastics. Beside that, the physical structure of the polymeric layer is important to have good barrier properties, and the chemical composition from these polymer layers are of interest. And how is the permeability measured? So there are, I guess, two important things. And one is the water vapor transmission rate. So that's here, the WVTR, and beside that, the oxygen transmission rate. That are the major things which are interested in packaging goods. And here you see simplified working mechanism from the equipment, which is used to check the barrier properties. You still have the film here inside. You have the flow from the material, from the, call it carrier gas, and you are looking what is passing by to the film, and then the water vapor is taken with the flowing gas into the sensor, and then it starts to measure the water vapor transmission rate. Something similar here for the oxygen transmission rate. So the flow carrier gas is still, again, nitrogen, and it's measured oxygen for that part. So with these equipments, if you have bought one, it's not possible to change it to other gases. So it's really focused on that what you bought, means water vapor transmission rate or oxygen transmission rate. Here you see our two equipments which we have. So it's MOCON measurements equipments, and here you get an idea how the film samples looks like if we prepare it. Coming now to our additives which might boost the barrier properties. It's called montmellite or clay. And in principle, if we dig it out of the ground, you see it's more or less like a big book where you have different pages. And what you want to have in your polymer matrix is you just want to have every platelet structure well dispersed in your matrix. That means every page should be well dispersed in the matrix. That's a must. And to speak about the general things from the montmorillonite, it's, as you can see here on this picture, it's a very platy anisotropic material, and the size is very, very small. So we speak in thickness from one of these pages about 1 nanometer and 200 nanometers in diameter. That means the material has a huge high aspect ratio, and that's quite important to get the real performance in case of the barrier. But the problem is, if we dig it out of the ground and will place into the plastics, we will never have good values, because we need to modify the clay with some organic stuff. And I keep it simple, not to focus on the chemistry. We exchange some ions and bring up these red dots or red lines, which you see on that point, with some organic. And with this organic, we bring up the platelet structure a little bit far away. And that means we make our life easier during your compounding step to exfoliate. That's how it's called. We can call it also disperse your platelet structure in the matrix. That is really the trick. The organic should fit to the polymer. That's also quite important, especially with the polarity and the thermostability. With saying that, I give you now an idea how this mode of action is going on with this mineral. So, of course, the simple way is you have your film, you have your gas, which is passing through without any big issues. So coming from this side, going over to that side. So no real barrier properties. If you have minerals like, for example, calcium carbonate or talc, they have a low aspect ratio. And what happens if you disperse them in the matrix? You see here, these gray parts should be the minerals, and the gas is passing around these minerals. And of course, if you have now a product which has high aspect ratio, the gas needs to take longer ways around the particles. And that's exactly the point what our mineral is doing. If it is well dispersed in the matrix, it increases the barrier properties due to the fact, so that's what we call it, due to the fact of this Toturiov path increasing. So if we start now with polyamide 6 or polyamide 6,6, and doing a compounding job with our clays, you get now an idea what it means if we introduce a material. You see it behaves more or less like a filler. Yeah, you see here there's a virgin material with an E-modulus like that, and you see if you start with 3 and 5% from the clay, you increase the E-modulus, but you will dramatically reduce the elongation at break. And of course, you will increase the HDD, which might be nice. And so in principle, the clay is behaving like a real mineral. If we look now in the important part, saying what does it mean if we speak about oxygen or permethrin increasing in barrier properties, you get here figures with 4% of one grade, which is called BYK CT4255, or 4% from a chloesite 20A. And you see with this performance of the CT4255, which exactly fits from the organic modification to the polyamide, we are able to reduce the permeation from the oxygen down to 55%. With an, I call it now, Wong clay decision, you have only the chance to get 28 or nearly 30%. Same with the permethrin. You see with the right clay grade, the CT4255, a nice reduction from 45% compared to the, I call it now, Wong clay with 25%. So that means a good decision in clay will improve really the barrier properties, and it's really important to take the right clay into your polymer system. If we check now as another example, the chloricide 20A, you remember that was still performing not so good in the polyamide 6, but here in the LDPE, you see with the oxygen permeation, it's really nice improving in that way. And interestingly, maybe you still remember, we were looking into the carrier gas, and beside the carrier gas during the measurements of the MOCON equipments, you can play with the relative humidity. That's also an important figure, but as you see here for the oxygen, the relative humidity is not that important like it is, for example, here for the permatran measurements. So you see with the different carrier gases, you have different values on your materials, but still nice improvements also here, again, with the chloricide grade. So in the case of the water vapor transmission rate, we can reduce it down to 50-20%. In case of the oxygen, it was around 30% of improvements. So the clay is still doing a good job in case of the barrier properties, and that should be shown here in this figure. If we have, for example, the polyamide 6, you might be able to reduce the oxygen permeation with 50% and also the relative permeation for the water to 50%. With the LLDPE, it was with 4% concentration of the clay into the film, around 25 to 30%. So nice improvements, one way to have a chance improving your barrier properties without different layer structures like it's classically done with an EVOH or a polyamide system into a tie layer system. So that's really interesting to follow. Coming now to the point of polymeric modifier. Here we have a huge toolbox where we can play around. So we have multiple products and processing in different ways. We have very high grafting levels from our materials. And if we follow here these blue bubbles, this should be the polymer backbone, could be different. So polyethylene, POEs, polypropylene, SEBS, or PLA or PET. So we have a lot of possibilities to modify polymers. And what we are doing is we playing around with a grafted monomer. So we have malin anhydride, we can place with an epoxy, we can place with an acrylic acid. So all this should be shown here with these yellow or red ones. It's just a simply toolbox, I would say, but very efficient, especially if you want to improve properties in your plastic applications. And here you get now an idea what these polymeric modifiers are able to do. So they can work as a dispersionates, and beside that, they can also reduce the warpage. That might be interesting for color master batch, especially for closers. And beside that, this modifier can be used as tie layers, so for multi-layer films to improve the adhesion layer between non-compatible materials, or it will increase the metal adhesion in film application. Beside that, it can work as a coupling agent for fiber filler and works as a reinforcing materials. It might also be used as an adhesion promoter for elastomeric components, for example, here for toothbrushes or grips of boxes, something like that. And one very interesting part, especially for the recycling, is the compatibilization. So that means if polymers like polyamide and polyethylene, for example, which don't like each other, are in an recycling material, those materials still work as a compatibilizer. So it can also work as a viscosity controller to improve the melt strength. That might be very interesting for biopolymers. And beside that, the materials are also used as a toughness modifier, for example, in polyamide. So if we look now in a use case of these compatibilizers, you still know that the recycling of multi-layer materials is really a hard work to do. And to come over these issues, especially if you have this big mixture of different stuffs, you get something which is inhomogeneous and has poor compatibility. It is very poor in optical or mechanical performance if you want to make out films again of that. And our solution is to work with these functionalized Kona modifiers, which works as a compatibilizer. So here is, of course, how it works. So we have the Skona modifier, and here these blue half pipes should give the functionality group. So that means here we have a malin anhydride group. And for example, if we have now a polyamide, which has on one end the amine group, it can react with the malin anhydride. And what is going on then is still you have a compatibilization between the different phases. So you have an unpolar and a polar part, which are now really bonded and really nice dispersed with high impact performance. What that means still in a mixture of a polyamide and polyethylene, I will show in a few minutes. So we have done some work with a standard polyamide 6 grade and an LLDPE. We used our Skona compatibilizer and we used a recyclable grade. And we did a compounding on a twin screw extruder. And with these granules, we went over to our cast film line and did some injection molding. And what we saw as a mechanical properties improvement you see here on that slide, it was a mixture between polyamide and LLDPE with 30 and 70. We take this figure because that's nearly very close to a packaging, which is, of course, a multi-layer structure with 70% LLDPE, means maybe on the outer side, and the polyamide is quite often used as a barrier improver, and that's a classical 30-70 mixture. What you see is if you have no modifier, you start up with 12 to 15, something like that. And if you use now recyclable 4374 or the Skona TSPOE, you see with the different amount of the additives, you really get a nice improvement for the notched Sharpie. Also here an idea for the other mechanical properties for tensile strengths and tensile modulus and elongation at the maximum. So you see, especially for the elongation at max, a really nice improvement with our different additives. And if we look now into an, let's say, picture taken with a microscope, we have here the control sample, and you see these big bubbles here without any bonding to the matrix. And that means these big bubbles are the polyamides, and the matrix is still the LLDPE. And like I said, there's no real bonding between these two polymers. In the moment, if you work now with our Skona modifiers, you see, of course, the difference. The particles are still smaller, and you see it starts really to bond to the matrix. So the polyamide is really bonded with the polyethylene, and that's exactly what you saw in the slides before in case of the improvement in mechanical properties. So what we found out during our experience, the optimum modifier concentration is already reached in the region of 3%. So especially here for the mixture of 30-70, and the notched impact was really increased by factor 6. That's really a lot. Beside these mechanical properties, we checked also the film, and what you see is the control is really bad. You see a lot of spots inside, so it's not a chance to look through the film. And with the 3% of the Kona modifier, you have really a clear film, and nice dispersion of the matrix. So with this, you can still work and play around and run up again some nice film samples. The next part which I want to present is still the PLA. And as you might know, it's still a biopolymer. And especially this kind of, let's say, polymer is increasing like hell in case of the packaging goods. It has a lot of good opportunities, but one of the weakness point is that the mechanical properties of this material is not the best. I will show you later on what that means. And for this reason, we have also modifiers which are called the TPPL series. And what they are doing, they are still based on a PLA polymer. And we did, you remember our toolbox modifications with this PLA polymer, and were able to run up a modification or grafting with a metal anhydride, with a GMA, so an epoxide functionality, or an acrylic acid functionality. You see how the materials looks like. It's more or less a powder which we are producing out of these modifiers, and coming now to the point what it's still doing in a PLA. As I said, the PLA is still bio-based and biodegradable. It has good mechanical strength and for the final good, high stiffness and medium heat resistance. It is transparent, printability, but the major weakness for this material, it has a low melt strength and melt elasticity. And beside that, the flexibility, or call it impact strength, is really limited. So that's the reason why a lot of people doing mixtures with the PLA with different blends. And here is coming now the point where our product might help. And I will show you what that means. If we look here into these figures which are showing the strength widening, you may wonder why we place on here strength widening. The reason for it is the strength widening is correlating with the melt strength. So means if the strength widening is getting big, the melt strength is also getting big. So we made these figures here with our MFR equipment, means we measure the strengths which are coming out of the MFR. And like I said, if the strength is getting wider, it means the melt strength is still improved. And what you see here is with different amount of our TPPL 1214, you are really getting nice improvement in the strength widening, which means we have really nice increasing in the melt strengths. Here you see some materials which are in the market. So epoxy oligomers are quite often used. And what we did is we used these epoxy oligomers in concentration of 0.5 alone. And beside that, we worked with our acrylic acid modified material in a combination. And you see also here with the traditional epoxy oligomers, we see some improvements, but the values which you can reach with our 1214 material are on a quite higher value. Here, this slide should show you or give you an idea what are the benefits with the PLA. And of course, like I said, the mixture with a PBS or PBAT can help to improve the weaknesses from the PLA. So as you see, it's very strong in stiffness, has some weaknesses in case of the elongation at break, but here might be helpful to do a combination with a PBAT or with a PBS. So that is what the people still doing outside, right? They're doing combinations with different bioplastics to improve the balance for the PLA. And here again, our Skona compatibilizer can help to incorporate these different bio-based polymers. Same mechanism like I showed for the polyamide PE modification, but now we have another partners to play around. So we have, of course, again, a malin anhydride Skona material, and we have a blend partner, which might be the PBS or PBAT. And what is going on now? The Skona PLA modifier is reacting with the blend partner and made again a good dispersion and improve mechanical properties and the adhesion from the materials. And that's what you see here on the figures. We did a mixture with a PLA and PBAT with nearly 70 and 30. We did some antioxidants, and we placed in here the PLA modifier. The 1214 is a GMA material, and the 1112 is an MSA grafted material. And you see here the improvements in case of elongation at break with same values, I should say, for the tensile strength. So this gives you also an indication that these products helps to bring a better compatibilization between the polymeric blends. Besides these polymeric blends, the PLA is quite often filled with wood and as a filler. And here the Skona materials can work as a coupling agents. Yeah, so that means there is a bonding between the MSA group and the OH groups, which are quite a lot on the wood. And here you get a better bonding on here on that, and means better mechanical properties and reduced water pickup. So all nice things to have in a wood-filled system. Here are the different grades which we have. So you see that the 1112 and the 5112 are both based on the malin anhydride grafting. The difference is the 1112 has a lower melt compared to the 5112. And both products are quite often used as a compatibilizer between different polymeric blends and could also work as a coupling agent for filled system. So we did this both grades just to help the people which are working in different MFR values. Beside that, we have the 1214, which is grafted with a GMA or epoxy group. And these are quite often used as melt strength enhancer. And we have the 1310, which is the acrylic acid grafted material. And if you remember a few slides ago, I showed it as a synergist for melt strength enhancement if it is epoxy functionalized. So it's working like a booster. So what we can say is the benefits from our PLA grafted materials is it can work as a compatibilizer between the different polymers. It could work as a coupling agent if we have, for example, fiber matrix bonding needed, or it can work as a viscosity modifier to improve the melt strength. And the interesting thing is, of course, all of them still bio-based and also biodegradable. Coming to the last point of my presentation with the nucleation aids, you might know that these nucleation aids are still often used in thermoplastic application for caps closures and trays or boxes. So you see these different pictures on here. And in application, it means it is quite often used for automotive, electronic parts, construction. So all of this where injection molding is taking place. We have two grades, I should say. The functionality is, of course, a nucleation. We have this Bitmex NU4230 based on a polypropylene or based on an LiDPE, depending on your polymer which you're using. The processing methods are quite huge, so it means you can use it for blow molding, injection molding, extrusion. It's based on pellets. Typical dosage is between 1 and 5%, And this 4230 material is just a combination of output and dimension stability and quality improvements. Compared to that, we have the 4232. That material is based on polypropylene, and that's designed to improve the output. I will show you in a few minutes what it means. So generally spoken, what are the nucleation agents doing? So of course, if you have non-nucleated polypropylene, for example, the nucleate starts to build up huge and small and very inconsistent particle size of the crystallinity phases. So that means also the mechanical properties could be reduced. If we have a nucleated polypropylene, of course, with the nucleation, we can control the size of the nucleates, or means the crystallinity phases are really controlled, and means we have a unique view on these things, and that really improves mechanical properties and also helps to improve the output on the machines. So the materials can be used during compounding or also during processing. So it's quite very general use of the products. And if we start here and look into the processing, you see the 4232 is just a product which has a very nice and high peak of crystallinity. It's with 127 higher compared to that what we have with a non-nucleated material, means you are able to form out quicker your products. The 4230 is quite also nice improvements, but not on the same level like the 4232. If we check now mechanical properties, you see now the advantage of the 4230. This is just here shown in tensile modulus and in tensile strength. You see that the values from these products are on a slightly higher value compared to the 4232, which is doing a quite good job. But as I said, 4230 is optimizing mechanical properties. On the gray side, you see other nucleators which are also doing a good job. But in case of that, compared to our material, we are more efficient, also with lower amounts. And just as a summary, in case of the tensile modulus, we can really increase it up by 20%, and tensile strength is increased up to 10% with both materials. So that is the benefits of the nucleation aids, means you can reduce the anisotropic things, so it might reduce also in case of shrinkage, and keep your dimension tolerance and warpage reduced. So effects which are coming with pigments, especially phthalo pigments, are tending to warp. The nucleation effect will help also here from the nucleation agent to overcome these points of the pigments. It will increase the crystallinity and might improve the stiffness and impact, HDT and CLTE, and of course the cyclus time is reduced, and that means you get more part out of the mold and you can form it out quite soon. So thanks a lot for your attention, and please allow me one slide here which is quite important, that are the contacts which you might remember if you want to get more details on the site on what I presented. So that's the point on me, and I guess it's very important that you know the people which are in Colombia. Here Carolina is our part of the distributors, and it's the AZELIS company. And beside that, we have one guy in Brazil, Carlos, which is taking care on our side So if there are requests coming over for the presentation, you can ask me directly. If you need sample or further help with materials and maybe some Spanish explanation of the stuff which I tried here in English, I guess might be good to contact Carolina or Carlos. Thanks a lot for your attention.
Thank you, Hans, for this conference. We have one question in the chat, so I'm going to read it to you. The question is, do you have data available on the reduction and oxygen transmission that can be achieved with organofunctional clays in polyethylene?
If I understand the question correctly, we have also clays which can be used in polyethylene. And the major point on here is, like I stressed out in the slides before, the dispersion or exfoliation. And here we need also the help of the Skona materials, because the clay is not so easy to disperse in polyethylene or polypropylene. And as you learned during my presentation, that's a major point. So you need a special machine. There are a few tricks in case of design on the screws and where you introduce the clay and which kind of, call it now, compatibilizer should be used. So if there is any need on that side, we can discuss that a little bit more detailed, maybe with Carolina or with the help of Carlos, to show you and give you some recommendations in the case of formulations. I hope that answered the question.
Okay, Hans, thank you. Yeah, they are asking a little more about if these clays, if you have information, if these clays are reducing oxygen transmission.
Yes. So yeah, that's still used, as I showed here a few slides ago. Here you see the Chloride 20A is used in an LDPE. Here's a water vapor transmission, and here is the oxygen, right? You see with 4% of, let's say, clay, you get really 30% improvement for the oxygen.
Perfect, Hans. Thank you very much. I don't see any other questions in the chat right now, but I would like to take this opportunity to encourage all of you to text and to send messages to Hans or Carolina with all your questions. Now I'm seeing something else here. Okay. We have another question. The Skona for PLA can be used directly into the extruder, or is it better to pre-process it?
It should be processed in a twin screw extruder. Yeah, so it needs a real compounding step to introduce these materials to get out this strength widening. So it's not enough to work with this like call it compound or concentrate or whatever. So it needs really a compounding step and means a twin screw extruder. So in a single screw, I don't expect that it gives the full performance.
Okay. Okay, so I have another question here. Is it possible to have NU4230 in pure form, not in pellet?
That is, let's say, one of the points which we can't change. So we end up with our Skona materials in a powder form. The reason for it is our modification step. Let me show you here this slide, just a second here. Yeah, all the grades which we have here from these PLA-based modifiers are powders. And the reason for it is if we're doing an I call it now step to make granules out of the powder, they start directly to react with themselves. So that means if you have it as a powder, it has still the functionality. But if we're doing a granule out of it, there's no chance to have the real functionality because it tends to react with themselves. That's the reason why we have it only as a powder.
Okay, perfect, Hans. Okay, we have run out of time right now. So as I was saying, we encourage everybody to write you to your email. If anybody wants to write through Acoplásticos, it's okay. We'll make the bridge. And just thank you very much, Hans, for this conference. Thanks to everybody who joined us. And well, we hope to see you in all the other conferences today.
Okay. Have a nice day and enjoy.
You too.
Bye-bye.
Goodbye. Hi, Hans. Carolina, ¿están ahí?
Can you hear me? Yeah.
Yeah, I can hear you. Okay, just give me 1 second. Ya voy. So thank you very much, Hans. We had around 47 people joining us. So Aleja is gonna talk with Carolina to send her all the information. And I think this is all for today, but thank you so much. I'm sorry that you had a little trouble connecting at the
No,
beginning.
that's, as I said, I'm not the best in case of electronics and computer, and I was so happy that it still works.
I get you. I feel you. But well, everything worked right, and we really had a good timing for your presentation. So I
Yeah,
think
it
it
was
went
great.
really well.
Yeah, thank you,
Okay.
Hans.
You're welcome. So
Okay.
maybe next time I come over to Colombia and doing it, I don't know, personally, directly.
Awesome. Yeah, that would be awesome. You can come for Colombia Plus. That's our
It's
trade
next year,
fair.
so
Uh-huh.
Next, is it every year or at which seasons are you
It
going?
is every 2 years, in normally like in September.
Okay,
Yeah.
let's see.
Okay. Carolina, Hans, thank you so much.
You're
And
welcome.
my pleasure.
Bye bye.
Bye.
thank you. Bye.